All right, hello and welcome everybody. Today's lesson is going to be on finding equations to parallel and perpendicular lines. So in order to help you, we gave you 4 different formulas. So at the top of your screen, you'll notice you have the distance formula, slope formula, and then 2 forms of writing down equations. We write them in either point slope form or slope intercept form, and we'll be going between those interchangeably. So throughout this entire video, whenever you feel the need to, please feel free to pause or rewind. If you understand something you want to move ahead, go ahead. So we're going to dive right into our first example. So we've got points A and B, and I've already plotted them for you. And we want to find the length of segment AB. So in order to find the length, we want to find the distance between points A and B. So I'm going to use my distance formula. So I need to designate which one are my x1 and y1, and which one is my y2, my x2 and my y2. So I'm just going to go in order and say this one is x1, y1, and this one is x2, y2. And we're going to plug that into our formula. So we're going to do 4 minus, putting my -2 in parentheses. It's always a good habit. And then 2 minus 5 squared. And then that simplifies to 4 minus a -2 is the same as doing 4 plus 2, which is a 6. So we're going to square a 6. And 2 minus 5 is a -3. And again, because it's a negative number and I'm squaring it, I want to put it in parentheses. So 6 squared gives me 36. Don't drop your square root. And then -3 squared is a 9. So combine it. You get square root of 45, which is, if you plug that into your calculator, it's approximately 6.7 units long. So in order to find our slope, you can either use the slope formula, or if you have a grid or a coordinate plane, you can just easily look at it and do rise over run. So for our rise, we're looking at the y, so if it's either going up or down. So going from A to B, I'm going down 3 units. So if we're going down, that's a negative. And then we are going to the right 1, 2, 3, 4, 5, 6 units. Going to the right is a positive direction. So that means our slope is going to be -3 over 6. And whenever you can, you want to simplify. So that reduces to -1/2. So now what we want to do is plug everything into our point slope form. So we're going to use this formula right here. Y minus y1 equals m times x minus x1. And all it is you plug in for your y1, your x1. So we had those right here. We made that our A. And it doesn't matter in the end if you use A or B, because it all depends on which one you designate as x1 and y1. And then we have our slope, which was given to us right here. So we're just going to plug that in. So in the end, we end up getting y minus, our y1 is a 5, equals, our slope is -1/2, x minus, and our x1 is a -2. So that's the only part that we're going to actually end up having to simplify. So nothing else gets changed. We're going to write this as y minus 5 equals -1/2 x plus 2. So don't distribute anything. This is our final answer right there. Okay, so that was point slope form. And then for our very last part, we want to find the slope intercept form. So that means we're going to be using this equation right here. Oops, sorry. And so in order to do that, we can either do 2 things. We can actually figure out what the y-intercept is and then do that, or we can go ahead and work from our point slope form and get it into slope intercept form. So the difference between these two equations is that in point slope form, I have the y's grouped together and the x's grouped together, but in my slope intercept form, it's actually solved for y. So that's what I'm going to want to do. I'm going to want to get everything away from my y value. So all I have to do is distribute the -1/2. So I'll write it over here. Y minus 5 equals, I'm going to distribute my -1/2. So -1/2 times x is -1/2 x, and -1/2 times 2 is -1. You guys can do that on your calculator, or just think about it as what is half of 2 and make that negative. So half of 2 is 1, and it becomes a -1. And now to get our y alone, there's only one step left. We want to add 5 to both sides. So we're going to do y equals -1/2 x, and -1 plus 5 is a +4. That is our slope intercept form in that case. And now, in order to identify what our y-intercept is, our y-intercept is this blue part right here. That's our y-intercept. And so in order to get that, all we have to do is look at our equation, and our y-intercept is 4. Okay? So right now I would like you to pause the video and try number 2 on your own, and then click play, and the answer will pop up for you, and you can check your work. All right, so hopefully you were able to get all these answers. So for the length of CD, you should have gotten 6.7, the slope -1/2, point slope form is y minus 3 equals -1/2 times, in parentheses, x plus 4. And then to find your slope intercept form, I ended up distributing the -1/2. So I got -1/2 x minus 2. And to get y alone, you want to add 3 to both sides. So in the end, you should be getting -1/2 x plus 1 is equal to y. And then because of this, our y-intercept is 1. And I wanted to show you on the graph that even if you were unsure, you could double check with your graph, and you can see that the y-intercept is at a +1. And if we go back to the previous one, it also ends up being at a +4. Okay, so what do we notice about segment AB and CD? What can we say about their slopes and y-intercepts? So looking at their slopes, they were both a -1/2. So their slopes were the same, but their y-intercepts were different. My top one was at 4 and my bottom one was at 1. So because they have the same slopes, we're going to say that they are parallel to each other. So we're going to use the two vertical lines. So parallel to each other. And the fact that they have different y-intercepts also helps us know that they're parallel, because if they had the same slope and had the same y-intercept, that would actually mean that it's the same exact line, that it's one on top of itself. But we don't want that kind of situation. We want the same slope but different y-intercepts. So that means that the two lines are parallel. Okay, so start off with number 3, and again, pause the video and then check your answers to see how you did with number 3. So figure out what all this information is, and then we'll get back to it. All right, so for number 3, hopefully you were able to get a length of 12.6, a slope of 12/4, which reduces to 3, and then your point slope form in the end should be y plus 6 equals 3 and times, in parentheses, x plus 1. And it's important to remember to always reduce and simplify whenever you can. So reduce your fractions, and whenever you have minus and negative, always turn it into a positive. And then to get our slope-intercept form, we want to take our point-slope form and solve for y. So in order to do so, we distributed the 3, so 3 times x, and 3 times a 1, which gives us 3x plus 3. Subtract the 6 over to get y alone, and we get y equals 3x minus 3. And so based off this equation, or based off the graph, we can see that the y-intercept is at -3. Okay, so once again, do number 4, pause the video, and compare your answers, and then we're going to compare graphs 3 and 4 together. All right, so hopefully number 4 was a little bit easier for you. The numbers were a little nicer because you had less negatives. For the length of it, hopefully you got 6.3. And for the slope, you got -1/3. So as you notice, you're getting some different answers. These lines are definitely not going to end up being parallel to each other. And then our point slope form is y minus 0, which is a nice change, equals -1/3 times the quantity of x minus 3. And that made finding slope-intercept form much easier. So the 0 ends up basically going away, and we're left with -1/3 x plus 1 after we distribute that -1/3. And then our y-intercept is at 1, and we can look at that from our equation or from the graph itself. So now let's look at these slopes and y-intercepts for these two lines. So for number 3, we had that our slope was a +3, or in other words, we can write that as a 3/1. And then our slope in the number 4 was -1/3. If you notice something, these two are almost the same, but they're not. They're actually called opposite reciprocals. And we say reciprocal whenever a fraction is essentially flipped. So 3/1 became 1/3. And then we say opposite because we're taking the opposite sign, or in other words, it's going from a positive to a negative, or from a negative to a positive. So whenever we have slopes that are opposite reciprocals and different y-intercepts, so we had a y-intercept at 1 and a y-intercept at -3, that means these two lines are going to be perpendicular. And we're going to write perpendicular with this symbol right here. So we're going to say perpendicular lines, and this symbol means perpendicular. So once again, perpendicular is when the slopes are opposite reciprocals. Parallel lines are when they are exactly the same. So let's fill in these two little notes. So if two lines are parallel, then their slopes are the same. And then if two lines are perpendicular, then their slopes are opposite reciprocals. And I'm just going to shorthand that. Okay? So for your homework tonight, what we would like you to do is answer the rest of these problems. So identify, given this equation, what a parallel slope to it would be and what a perpendicular slope would be. So do that for those 3 problems. Write down the equation of a line parallel to this line. So think about what kind of slope you would need. And this is the given point. Same thing with the next one, but it's perpendicular. And then determine if the lines are parallel, perpendicular, or neither. So once again, look at your notes for what it means to be parallel and perpendicular. You want either the same slope or an opposite reciprocal slope, so maybe use slope formula. Okay? Please have fun and ask questions if you have any.